subphylum is the Phylum Cnidaria.
Phylum Cnidaria is composed of jellyfish, corals, anemones, hydrozoans, and even more organisms. These animals live exclusively in aquatic environments, most of these environments being marine environments. Lacking bones, most cnidarians are supported by a layer of jelly-like mesoglea that makes up most of their mass, and they may be either free-living or they may live out their lives attached to surfaces as polyps. Members of this family have radial symmetry, allowing them to detect and respond to stimuli from any direction. Another one of the key physical features they possess are cnidocytes, which contain nematocysts. Nematocysts are like little hypodermic needles containing neurotoxins. When triggered, these nematocysts inject this venom into prey. This is the primary way by which these organisms attack and defend themselves.
In addition to the obvious intrinsic values of such interesting organisms, they provide several ecosystem services as well.
Ecosystem services are processes through which natural ecosystems and the species that make them up support and fulfill human life.
One of the most well-known groups of cnidarians that provide these services is coral from the class Amphizoa. These immobile invertebrates encase themselves in a calcium carbonate coating to deter even most determined of predators. Although seemingly unable to contribute significantly to their communities due to their lack of movement, these colorful corals create an environment that supports many ecosystem services, including protecting the shoreline from erosion by blocking high-energy waves, sand development for the bioerosion of limestone skeletal material, promoting the growth of mangroves and seagrass beds, maintenance of biodiversity, providing coral blocks, rubble, and sand for building, providing materials for production of lime and cement, mineral oil and gas, providing materials for jewelry, live fish and coral for the pet trade, waste assimilation, providing a way to accurately monitor the pollution and climate records, and, of course, tourism.
Another commonly observed group of cnidarians can be found in the subphylum Medusozoa. These are the jellyfish. Unlike corals, whose adult form is a polyp, the adult stage of the jellyfish takes on the mobile form of a medusa. Within this subphylum, the true jellyfish from class Scyphozoa are a source of food for humans, a multi-million-dollar industry in Asia, and also a source of food for many marine animals. They may also be a check on certain major fish populations by competing for zooplankton and other small invertebrates that are the preferred food for many fish larvae. However, perhaps one of their most important ecosystem services is carbon sequestration and transport through the water column and then to the seabed when they die. Sloppy feeding behavior provides nutrients to support primary production. Swimming of large swarms contributes to oceanic mixing through displacement of water. They are the source of novel compounds such as green fluorescent proteins, and they are culturally important as well. Other classes provide services as well. However, one of the more interesting cases is the cultural service of the Portuguese man of war from class Hydrozoa. The people of northeastern Brazil have a traditional remedy for asthma involving the brewing of the Portuguese man of war into a tea. Although no research has been done validating this use, other members of this phylum are being studied for the potential medical benefits of their venom.
In order to protect our coral reefs, international cooperation is a must.
Nations need to work together to minimize pollution and runoff seeping into our oceans, manage the frequency and duration that at-risk reef sites are visited by tourists to decrease wear on the reefs, cease the collection of fish through cyanide fishing, which affects all organisms in the area, regardless of whether or not they will be captured, and address the issue of coral bleaching caused by climate change. Jellyfish, however, are a different problem, although one that requires no less international attention. In recent years, there has been an explosion in jellyfish populations, thought to be a result of the rising global ocean temperatures due to climate change. As they reproduce and feed, they outcompete other organisms, causing steady declines in other populations. In addition, jellyfish are attracted to the warmth of coastal nuclear power plants, where they often clog intake pipes and cause other problems. A multifaceted approach is needed in order to deal with the surplus of jellies. Some possible solutions are to simply harvest more jellyfish for human consumption rather than raise them in farms, or to remove them directly from the environment just to dispose of them. Also, restocking of natural predators of jellyfish, control of nutrient runoff in these areas, increasing the dissolved oxygen concentration where they are prevalent, and reducing the overfishing of fish species that compete with jellyfish for food are also options.
In class, we discussed the necessity of a multifaceted international approach to the protection and maintenance of coral reefs. This idea was not only supported in the literature, but was emphasized and repeated over and over again. No literature conflicted with ideas and concepts we had in class, but while in class we lamented how unlikely it was any of these ideas would come to fruition, the literature spends its time outlining realistic approaches to solve these conservation issues.
Phylum Cnidaria is an extremely fascinating set of animals, but they are also extremely important and deserve your consideration.